In this problem, we're asked to consider the equilibrium shifts that will occur when each of several different events happen to a gaseous equation. In the equation, notice that we have 2 moles of SO3 on the left side, 2 moles of SO2 along with 1 mole of oxygen on the right side, and a positive delta H value of 197. Starting with part A, if we increase the amount of oxygen gas, that is, we take something that's on the product side of the equation and increase its concentration, then the shift will be away from the increase to bring conditions back towards the initial equilibrium. That means making more SO3. And since they're asking us in this problem specifically about what happens to the moles of SO3, we're going to have to answer each question with that in mind, that reference. So here, the number of moles of SO3 will increase because it's a shift left. Part B, the pressure is increased by decreasing the volume of the container. Well, in the equation, everything is a gas, and we have 2 gaseous moles on the left side of the equation. And if you add together SO2 and O2, that's 3 moles of gas on the right side of the equation. An increase in pressure will cause a shift toward the side of the equation with fewer moles of gas because the equilibrium shift attempts to relieve the increased pressure. So the shift left is indeed the side where SO3 is present, and so we see an increase in SO3. Part C is a really interesting one. The pressure is increased by adding argon gas. Argon, of course, is a noble gas. That means it's not going to react, and furthermore, it's not in the equation we're considering, so it's not anything you need to worry about in terms of reactions. But the pressure does increase. The total pressure of the gases will increase if you add an inert or unreacting gases. Remember this, gases are mostly empty space. The new argon gas particles are simply going to fit into the empty space that is already present in the gases in their reaction container. It's just going to intersperse among those other gas molecules. Yes, there will be an increase in total pressure, but pressure on its own isn't what affects equilibrium. Rather, equilibrium shifts happen when we bring molecules closer together, closer to each other, that is, the intermolecular distance either increases or decreases. That's what affects equilibrium, not pressure on its own. Now, pressure changes are manifest when volume either increases or decreases, but those volume increases or decreases change the intermolecular distance, and that's why the equilibrium shift occurs. By adding the inert argon gas, we're changing the pressure, but we're not doing anything to the internuclear distance. And so the equilibrium stays exactly where it is. Part D, the temperature is increased. In this reaction, the delta H is a positive number, positive 197. That means that the reaction is endothermic. If it's endothermic, that means the reaction requires heat to be continuously added in order to make the reaction go. To make things easy, my suggestion is to treat heat as though it were a reactant. So I encourage you to rewrite the equation with heat written in line with the actual reacting chemicals. Now we know, of course, heat is not a chemical, and it's not going to react the way a particle would. But it's very helpful for considering the equilibrium shifts that involve temperature. So in this question, they say temperature is increased. So that means the amount of heat energy is going up. It's as though you had the concentration of a chemical that went up, and the equilibrium shift would always be away from the increase. So due to the temperature increasing and the fact that this is an endothermic reaction, we're going to shift right. A shift right is a shift away from the species we're asked to consider for each of these parts of the question. So the amount of SO3 will decrease in this case because it's a shift right. Okay, last one. Gaseous sulfur dioxide is added. Sulfur dioxide is one of the chemicals. This one's kind of easy. So you've got sulfur dioxide here, and they're saying it's added. Well, you'd shift away from the increase, shift towards the reactant side of the equation, and that reactant side of the equation includes SO3. And so that's increase.